and welcome to Space. This month we're here in the French Alps to see how scientists are using information from satellites and from places like this in order to find out what's really happening to our climate today, now, in 2015. But first, let's have a look at some other news from the universe this month. ESA's service module for NASA's Orion spacecraft has arrived in the US for testing. Europe's part provides propulsion, water and air to the spacecraft, which is designed to visit the Moon and Mars. 12 men just finished an 8-week bed rest study at the German Aerospace Centre. They did horizontal jumps a few times a week to help scientists develop new exercise regimes for astronauts. To our main story now, and the global effort by scientists to try to understand what's really happening to our climate right now. It's November in the Alps, and the first fall of snow covers the summits of Europe's largest mountain range. Here, 3,200 metres up, near the glacier of Les Deux Alps, the reality of climate change is measured and recorded by scientists like Jean-Pierre Dedieu.
Here in the Alps, the verdict on climate change is unequivocal. There's really a split compared to the conditions we were able to observe as little as 20 years ago. It concerns the snow. The glaciers are losing surface area and volume, so we need to follow it closely with satellites, as they can take over from the ground measurements, which are only limited.
Compare satellite views from 1985 and 2015 and you can see how the glacier has shrunk. The reason is the greenhouse effect. This year CO2 levels hit 400 parts per million, their highest level in around 3 million years.
That's a core drill. It's used to measure the water equivalent of the snow. I take the standard parameters of the snow. So that's the temperature, the density, and now we're going into the first layers inside the blanket of snow. -3, -3.5. We look at the size of the grains of snow too. The measurements are done every week, and when we have a satellite pass, we try to do it simultaneously.
Data shows there's now less snowfall here and the summer temperatures are higher. So what's happening?
The Earth is a closed system. The water doesn't go out into space, it stays, but it falls elsewhere and in a much more intense way. That's why we have more and more extreme weather with cyclones and storms in parts of the world, which used to have them sometimes, but not as often as today.
The launch of satellites like ESA's Sentinel-1 and its predecessors ERS and Envisat means scientists can monitor the least accessible parts of the planet. So researchers like Fanny Brun can use optical and radar satellite data to see how the Himalayas are responding to a warming planet.
Over the last decade, the glaciers of the Himalayas have generally lost mass. With these new satellites, we have a much higher resolution. So we can not only evaluate the mass of the glacier again, but we can also see in detail the areas where the glacier is becoming thinner and subsiding. And that's very interesting for us because we can understand the processes behind it.
There are dozens of Earth observation satellites in orbit. They measure things like soil moisture, deforestation, ice thickness, atmospheric gases, ocean salinity, and since 1993, they've been measuring sea level height. They show it to be rising a small but inexorable 3.3 millimetres per year. We met up with satellite altimetry specialist Annie Cazenave in the southern French port of Collioure.
The sea continues to rise, and that we can see regularly thanks to satellite data. So our estimate of 3.3 millimetres per year is very certain now. In the Mediterranean in particular, here in Collioure, the rise is about the same as the average.
Three factors contribute to that average. 10% is groundwater pumped out for irrigation, 30% is the water expanding in volume because it's warmer, and 60% comes from glaciers and ice caps melting. But the 3.3 millimetres is an average. In some places, the sea level rise is much higher.
This map shows the different variations in sea level over the past 23 years. Where the map shows orange and red, it means the sea is rising faster than average. It's basically because of the way heat is stored. It's not uniform, it changes from one region to another. And here in the Western Pacific, the sea has risen up to 4 times faster than average, the average being represented by the yellow areas.
It's clear that space technologies have transformed our ability to gather data and give us a global view of climate change. So where does that leave us now?
Now, in 2015, we're facing our responsibilities, and these responsibilities are pretty obvious. The scientists are trying their best to present a diagnosis, like doctors at a patient's bedside.
The observations are categorical. The climate is changing. The big question is, could we fear a sudden change in the decades to come? And there, I must say, we really don't know.
There have been longer or shorter variations in the climate since the dawn of time. The worrying problem at the moment is that it's happening over a very short period, on the timescale of the life of a man.
More greenhouse gases in the atmosphere, warmer average temperatures, rising seas and melting glaciers. That is the state of planet Earth's climate in 2015. Away from climate change now, and to our regular update from the Astronaut Academy in Cologne. We met up with British astronaut Tim Peake just before he blasts off to the ISS and asked him what happens if things don't go to plan.
0.06, bridge rate. Target is
Hello, I'm Tim Peake. I'm an astronaut with the European Space Agency, and I'll be launching to space to the International Space Station on the 15th of December this year. One of the hardest things about being an astronaut is learning how to be efficient and flexible. If something goes wrong on board the space station, we have a lot of people who've put a lot of thought and time and effort into how we should react to certain scenarios. If a piece of debris, for example, were to hit the space station and it were to start losing pressure, then we need to try and find the leaking module as soon as possible and isolate it so that the whole space station doesn't go to vacuum. If that fails, then at a certain point when things start getting dangerous, we'll actually evacuate the space station, go to our Soyuz spacecraft and undock and return to Earth.
Undocking confirmed.
That's all for now. Next month, we'll be at the COP21 Climate Summit in Paris to find out what the future holds for planet Earth. See you then.